Okay, well, welcome everybody. This is George Leoniak with Charlie Ziese today of Stargate Pyramids and Pyramid Science Foundation. I'm super thrilled to have Charlie on the show today for this awesome new conversation. Uh, Charlie is the author of this amazing book, 76.345 angle, the exploring the hidden secrets of the Golden Ratio. Now, many people who are watching my channel know that I do so much work with the Golden Ratio. So when I found this big tome, I was like, this is amazing. And what is the 76.34 angle? I've been doing sacred geometry for a while and didn't find it really on my own. Although I started to realize it was in the Russian pyramid and through Charlie's work and starting to work with the drawings. So I've been doing a lot of sacred geometry drawings. We're going to share some of that. And Charlie has also brought an amazing amount of content in a presentation that he'll be sharing too. So I want to just greet Charlie. Thank you for being here. Please chime in and share how it's going for you today and anything else you want to add to our coming together story about all this.
Well, George, thank you for having me. This has been a real fruitful several weeks ever since we connected. I as we'll discuss later. I mean, I wrote this book knowing that there were that this angle was significant for two major reasons, and the first one we'll talk about is that this angle, which turns out to be the angle of universal Phi scaling, is in geometry all over the world. So that was important, but I also knew, not really being a sacred geometry person, I had been able to delve into how math and geometry kind of came and harmonics all fit, but I was missing the sacred geometric side of this. So when you called me 3 or 4 weeks ago, I'd been doing a lot of work and presentations primarily on just alerting people that all this old architecture was around. But now that you have joined into this effort so quickly and so tremendously, I knew it was time to start to really gear up again on the research side of this. So it's been a wonderful couple of weeks, and I can't wait to let everybody start to see what you've done. But to do that, what I thought, especially for your audience who are not going to be as familiar, I'd give a little bit of background as to what's in the book, and then just begin to put together the bits and pieces that I had been able to put together as to how all of this was going to come together. And that's what you're going to demonstrate, in the second half of the presentation. So
Awesome.
I guess if it's okay, we'll get started. I have a bunch of slides to show everyone, and
Yeah, great. Let's jump
we'll
into it.
okay, we'll get started. So this is the cover of my book. Again, one of the errors that I discussed with George early on, I shouldn't have titled the book 76.345 because it should have had 3 dots after it, because this is based on the Golden Ratio. And so it really, to be more precise, it's 76.345, and it goes on for quite a distance because it's based on this principle of the Golden Ratio. But anyway, in the book, as you can see, this is an example, one of I think I have over 1,000 photographs in the book, which demonstrate that mankind has known about this specific angle for thousands of years. This is a ruin in Africa called the Great Zimbabwe Ruin. I'll just tell your audience briefly, it's estimated to be probably 500 to 700 years old. But researchers, Michael Tellinger and Dr. Sam Osmanagich, have measured the ionization field of this, and it was off the charts. And they had no idea, and may still not, why that field was so strong. And the argument that I make with hundreds of photographs is it's the geometry, and we'll get into that. But we can look at Buddhist and Hindu temples, Gothic cathedrals, obelisks. Our DNA has this geometry. It just goes on and on and on. So we're not going to talk about that today, except I just want to alert people. If you're interested in all of that, you can come and look at some of my videos. Obviously, you can buy the book. And, George will tell you there's plenty of examples of this in all continents, all time frames, all major religious traditions. And of course, the big question that comes about once you see this, you can't unsee it. You'll say, well, how come we don't know about this? And that's a whole separate topic that we're not going to get into today. But I think, George, your audience probably is aware, as mine is, that this technology is stuff that's not really the people who seem to control our media and our history and our everything else don't necessarily want us to know about. So I think that's a big reason why all of this information has been withheld. But as I point out in the book, and we'll be getting into later, research from Russia on the pyramids that I build, which is really the way I got into this, all indicate that this geometry creates free energy, it creates health and longevity. So there's lots of stuff in that we'll be able to, hopefully over many chances to do videos together, we're going to be able to demonstrate through sacred geometry, through harmonics research and the like, that this field is the field for energy implosion technology, as well as provides a coherent energy field, which is a key component of health. So anyway, with that said, I've told a lot of this already, but prior civilizations had a sophisticated knowledge of sacred geometry and apparently universal Phi scaling as well. And that's demonstrated in the book through hundreds of examples of this angle in ancient and contemporary architecture. These examples range from thousands of years ago, actually in some cases hundreds of thousands of years ago, to as recently as about 100 to 150 years ago, when this geometry began to fall out of favor and disappear from contemporary culture. Now, the only place where you see it today in contemporary applications is in technology, where, for example, in aerospace applications, you'll find that rocket ships, airplanes, missiles, anything to do with aeronautics or nautical engineering have this geometry. And it's because this is a very special angle. But you won't find this in the traditional municipal or religious architecture where it was found up until, as I say, 100 to 150 years ago. So the second thing is that the research demonstrates the essential role of 76.345, the slant angle, and universal Phi scaling in cosmology. And it demonstrates that there's an order and a process for ordering and structuring the universe, which uses mathematics, sacred geometry, and harmonics as part of the creative process. And then the two last bullet points, as I mentioned, this is research further points to 7645 and a scaling unit, which we're going to talk about, that comes from this geometry. It's all key to such concepts as fractal scaling. We're going to talk about the Platonic solids and the progression within this geometry. So all of creation is and the creative process is we are going to be demonstrating is done within this geometric angle. And then finally, there has been a deliberate effort on the part of powerful forces to keep this information from us. And, we're not going to talk about that today, but that's a major component of the information in this book. So in summary, this is a picture on the left of the Russian pyramids. The Russian government actually funded research and built these pyramids over the last 30 years. There was a director named Dr. Alexander Golod, who led the Russian pyramid research. It dealt with areas such as personal and public health, free energy technology, agriculture, material science, environmental remediation. So they're just amazing results that occurred from this. And this is how I got interested. This information was brought out about 6.5, 7 years ago by David Wilcock in a series on Gaia TV, where he did a 10-part series on these. And no one was making them. No one knew the geometry of them, much less. But I decided this was going to be something that I wanted to pursue, and that's how I really got started. Now, taking that information, one thing I want to point out, the Russians attempted after the fall of the Soviet Union to publish all of their research information in the West, and I would expect that would have included the sacred geometry of the pyramids, but that was not allowed to be published in the West. So I had no idea when I started 6 years ago about the significance of sacred geometry in pyramid function. So I had to guess and divine how to derive this angle. Now it's easy, as you can see in the photograph. I learned early on that I could take a protractor app on the and measure the slant angle of various objects such as pyramids and cones and the like, and steeples on churches. But when I looked for a Goden Ratio relationship, I couldn't find it. If you think about the Giza pyramid, you can find it in the height to base length ratio, for example, or in other designs, you can find it in the slant or slope height to base length ratio. But I couldn't find it. So I started reading Robert Lawler's text, Sacred Geometry, Philosophy and Practice, and that's really where I got this original idea. All I knew was that I was seeing a lot of circles involved, and I knew that circles or spheres in 3 dimensions were probably the basis of the creative process. So I just came up with an idea. It was actually, I'd say that I was led to this by in my kind of in my meditations to try this. So what I did in the center, I just took a circle, or in this case in 2 dimensions, with a diameter of 1, and I started stacking circles on top of it. Each circle diameter was decreasing by 5. So you can see the first one was 1, and then you divide 1 by 1.618, you get 0.618. Do the same thing, 0.382, and so forth. And then I built a simple triangle in 2 dimensions around it, and we came up with the geometry of 76.345. Now, this is where the fun's going to begin, because all of a sudden I started seeing this geometry in natural phenomena. For example, the refraction of light, as it turns out. This is an experiment on the left by a researcher named Clay Taylor. He took a pipe, put a spherical glass ball in the end of it, and then shone light through it, and it refracted, and sure enough, it turned out to be this very angle. Similarly, we can't see sound, but I looked at old style megaphones before they became electronic. They actually had to use sacred geometric principles to magnify the sound of through the megaphone, and sure enough, it uses that same geometry as well. So I knew that I was onto something that was fundamentally significant in terms of the way the world was actually put together. The next important one that I found was not immediately obvious, and isn't obvious to many people. A lot of people would ask me the question, well, Charlie, your pyramids look a whole lot different than the Giza pyramids. They're so much, they're steeper. They're so much steeper. But I sat down and I looked at the geometry of the 2 pyramids, and I plotted them with a common base length. And what I found was the following. that you see phi everywhere. The golden ratio is everywhere here. But the most important thing that I found for our discussion right now was that the slant, or I believe, George, you used the term slope angle, but it's the same thing. You can see it down at point F here is 76.345 degrees on the Russian pyramid. But strangely enough, when you look at the apex angle of the Giza pyramid, did I say that backwards? Yeah, it's 76 for the Russian. And then up here, it's for the Giza pyramid, it's 76.345 as well. So that was, I knew, highly significant, but I didn't know why. And I didn't know why until literally last week when George showed me why that's important. And so I'm going to stop here for a minute, because all of a sudden sacred geometry to me is taking on a whole new significance because of the work that George has done in just in this one area. And then we're going to talk about this in other contexts later. But take it away, George.
Yeah, great, great. Well, Charlie, that's super fascinating. I just love the parallels, because we've double checked all our numbers and we've gone about it in very different ways to come up with the same results. I mean, Charlie wasn't really even on my radar till about 3 weeks ago. You know, I mean, I hadn't researched Charlie's work. I didn't know about the book. And I saw a picture of the Russian pyramids in a star-cut diagram book by Malcolm Stewart. And he had a picture in there and a technique to draw it with using the star-cut diagram. And I tried it out and I was like, that doesn't seem like it's working out for me. So I was like, I know a lot about the golden ratio. What can I come up with to produce this? And I just started working with it and didn't even know anything about the significance of the angle, but was testing it out with the stacking the phi spheres, which I'm not showing you here. And this is just one method that I'm showing you here of probably about 8 that I've come up with that can recreate this angle. And all the drawings that I've shared with you, all the Platonic solid drawings, everything that I've done on my channel, this was hidden in the geometry of everything that I've been doing the whole time, especially the material that we'll talk about, Charlie and I will get to, probably not in this video, but some point in the future. All those implosion diagrams that I drew, Dan Winter's work, I have a whole series about the star mother and the star child version of that I created, about these scaling the phi ratio circles, you know, infinitely down into the center. Well, what I discovered, and we'll get to those images later, is that basically all those concentric circles of golden ratio that aren't being shown here are essentially the pyramid looking at it from a top-down perspective. So what I had to do is just basically turn the stacking of those spheres on the side, and there's the angle. It showed up. But I didn't quite know how to recreate it with sacred geometry techniques. And that was huge. And I think it is huge to have discovered these methods for recreating the angle that anybody can do with a hand-drawn compass and techniques. This was done in GeoGebra, however you pronounce that. But it was done in there. But this is a technique that you can do. And I showed Charlie the other day. He's like, how do you do this, right? And I just whipped out the iPad. And how long did it take, Charlie? We'll show a video of that at some point.
I was just blown away. It took you about maybe 90 seconds to show me from start to finish how to do it. And you did it with a compass and a straight edge. And I mean, I'm just blown away.
So. It was fast, right? But it's so simple that something so amazing and so universal, as Charlie's pointing out, at all the places that it shows up in classical architecture, as well as in nature, and the scaling angle at so many demonstrations that Charlie points out in his book, so many presentations, didn't have a technique to draw in sacred geometry that I know of. Now, maybe this is something that the Russian scientists knew about, but whatever was happening with these drawings was totally new to me, that I've never seen anywhere else. And I was on a roll for about 3 weeks. Charlie probably couldn't keep up with the amount of images I was showing them almost daily. You know, new presentation, I want to add more and more to it. But one of the things that I discovered early on was the relationship to the Giza pyramid inside the Russian pyramid. They weren't separate. And there's a lot of mathematics in relationship to the proportions we see between the side edge to the size of the bottom square of the Russian pyramid, the base, to the to the Giza pyramid. Those are all showing phi proportions all throughout it. So it's another way to show these phi relationships at a different scale than what Charlie was just showing you previously. But in drawing it with sacred geometry techniques, there's a direct link between the two. You actually need the help. You need the Giza pyramid in some of the techniques to get the appropriate places to draw the Russian pyramid. So there's this sacred geometric language that these two are in relationship to one another. And that led to, you know, creating these models of figuring out how to nest it. And there's the bottom, right, of these two squares, one inside the other. Amazing models, just one of many that I've been constructing. But like Charlie was saying, we wanted to test out all the mathematics to make sure that what he came up with through his techniques were showing the same results based on a 1-inch, you know, base S to T for the pyramid. Now, whatever you set the numbers to, everything's going to change, but all the ratios are going to maintain. So we were double checking our ratios to see how the technique of Charlie working with the incremental units, stacking spheres added up to this. And yeah, it all adds up. So, you know, I was pretty thrilled. Here are the angles of the two pyramids, the 51.827. I did this in 3D on the GeoGebra 3D calculator. That took a while to figure out how to do, but I could rotate these around, get all the scaling angles. So there's a lot of numerics that I'm not showing in this of all the information you'd ever want that we'll probably at some point put a compilation together to, I have a more well-defined source of all these numbers. Charlie has a lot, but there's another way we can compare to the Giza pyramid at this scale too. So that's just a brief intro to where we have been at and what I've been up to on my end. And I'm only going to scratch the surface to the amount of drawings. Like I said, this is just one of the techniques. It's actually the last one that I came up with. There's a lot more easy ones to do than this one. But I really like the look of this one with the Goden ratio all throughout the scaling of these circles with the 1-inch circle in the middle. So Charlie, that's just a brief overview of, you know, how we got together. And it was really through the discovery of these drawings that I was looking for Robert Lawler video online, and I happened to see Robert Lawler and one of Charlie's videos around the Platonic Solids linked together. And I was like, wait a second, Russian pyramid, I'm drawing that. Like, I'm deep into this right now. It was about a half an hour before I discovered this awesome method to do it. I'm like, I'm just calling Charlie up. You know, I got to share this with Charlie. I don't know if he's going to pick up the phone. You thought it was a Comcast caller. But as I've watched a few of your videos, you seem so inviting and welcoming. You usually say at the end of them, give me a call. I'm looking for people, you know, to join me in discoveries. And I guess I just came in at the right moment in time.
Yeah.
So thank you for being open to, you know, people exploring.
Oh, listen, that's what this is all about. I you know, I'm the first to admit this world, I was able to learn enough about sacred geometry principles to where you could link to this and I could, so, you know, we're now kindred spirits because we're chasing after the same thing and getting this information out. But, you know, where I was taking my book, I mean, as I mentioned before, the main part of the book was showing that this knowledge has been around for so long and demonstrating that. But I had already started to put some of the pieces together for a model of that's going to show, and that's where we're going to go next, that we can take this static information and we can start to build a scaling, a model of scaling really the creative process within this geometry. And that's where this stuff gets really, really exciting to me. So I don't know, should we move forward?
Keep going. I guess this is the last part I would say on this is that with these drawn techniques, it's really introducing this into the huge pattern of language of sacred geometry. And I think that that's going to give folks an opportunity, other geometers or people who are very new to sacred geometry, to start to explore working with this angle. And it's a real transformative process, as I often talk about in my videos. But this is a way to start working with this pyramid. I have templates of awesome designs. You can fold out the pyramid, fold it up. You can do it all, right? So this is a way that's going to introduce it into the geometer's toolbox of techniques and templates. This is now like, going to be infused into that pattern language, which would seem like a big missing link to me in the relationship to why so little has been known about it. Yeah. And I think much more will be with the help of diagrams like this and people being able to interact with it through their drawing techniques or seeing the imagery like this will be huge in that influence of, getting more awareness about this pyramid too. So thanks, Charlie.
Before we leave this diagram, there was something you told me last week. I don't remember the ratios, but you said there's an interesting relationship between the area of the base of the Russian pyramid inside the Giza.
It was actually the edge lengths are
edge length. Okay.
Yeah, the edge lengths are actually the 3.236, which is part of the phi ratio. So the edge length of the small one to the large one, well, it's right here, right? The edge length of the small one is 1. The edge length of D to B is the 3.236, right? So that's square root of 5 plus 1. You divide that in 2, you get 1.618 on either side. So U to B, that's half the pyramid, that's 1.618. And then the edge length of the Giza pyramid is 2.618, and the height is the 2.05, which is the same height for the Russian pyramid when you scale it to a 1-inch base, right? So it all just added up. So these are amazing numbers. 2.618, the ratio between the two. All this is a lot of ratios based on the unit 1 being based on the Russian pyramid base, because a lot of this is Kepler's triangle, it's known as, the Giza pyramid, Kepler's triangle. You base this on 1, then all these numerics will be totally different. Even the Giza the Russian pyramid will have different numerics, of course. But I thought this was a nice way to show the relationships based on the Russian pyramid having the 1-inch base. So many ways you could demonstrate it, but it was congruent with what Charlie had done.
It is. Just to step back, you can see, I had ratio relationships, but I had a common base length rather than a common height, but the phi relationships were everywhere. So it all matches up. We came at it from totally different directions, but we ended up with the same basic, the exact same angles and relationships.
Perfect, so. Charlie. Yeah, keep going. Let's keep going. We got so much. I hope we keep going.
Well, now what we're going to do next, I'm going to give the audience just some basic information about scaling that I had figured out as of the time that I published the book. But I knew that I had to get in touch with someone like George who understood this and could translate this into sacred geometry. But with that said, what I found in a lot of different places, it's in the world of fractals. I'm going to show it here in a section of Lawler's book dealing with the science of mediation. That phi cubed slant height of 4.236 or phi cubed started showing up everywhere that I was looking. So I want to this was the first place that I found it. We're not going to spend a lot of time on this today, but for those geometers who know Robert Lawler's work, this is all based upon chapter 8 in his book of Sacred Geometry and Philosophy and Practice, and it deals with what's called the science of mediation. And I just want to go over some basic terms so you can relate to this, and I'll show you some results, but this is probably, again, worthy of a whole separate discussion or video. But Plato used what he called a 3-term continuous proportion. And what that means is, in mathematical terms, A is to B as B is to C. And I think one way to look at it, let's read what Lawler has to say about this, and this will give you some context. The laws which govern the creation of things are the same laws as those which allow for their comprehension, and essential knowledge is an understanding of these laws. Such knowledge can be gained, Plato says, through the study of mediation, which is the binding of two extremes by a single mean term. Now, I don't want to get too involved with this, but I've started to think of this since I believe that our thoughts create our experience. And in fact, the fact that we can find this kind of scaling geometry in nature tells me that there is a process through which that can occur. But one could even philosophically or theoretically think of us, our consciousness, as being B, which is sort of the connection point between that which is seen and unseen, to take the terminology from the Bible. So in geometric terms, or mathematical terms, mediation can be viewed from three different perspectives according to Plato. There's the arithmetic, geometric, and harmonic. Now we start to get into the world of harmonics from geometry and sacred geometry, and each of these has a specific formula. With that as background, what I started to find out, and again, we're not going to go into this in great detail, but when you look at these three means, what I believe Plato was trying to teach us in that statement was that in order for the world, for us to scale things accurately, we need to be able to take, we need to keep all of these in perfect harmonic, arithmetic, and geometric relationship. And in order to do that, there are two things that came out of this analysis that I did that are important. One is called the scaling unit, and one is called the scaling rate. The scaling unit is how big is this object going to be, this unit? And so to define that, I say for any two initial number pairs, A1 and C1, the scaling unit is the ratio of the value of C1 and A1. So if we start with, I've made these simple so we can see how this works, but if A1 is 0.2361 and C is 1, then the scaling unit, which is the ratio of those two numbers, is phi cubed, because you divide 1 by 0.236. Now, if we weren't using a sacred geometric relationship, we could just look at an arithmetic relationship of 1 and 0.5. Well, then that scaling unit would be 1 divided by 0.5 or 2. So that's the way you do this. And you'll see this on the chart here in a minute. So that's what a scaling unit is. And then the scaling rate is, now that we've come up with these two numbers, and think about the Fibonacci sequence as we're doing this. These two number pairs, I don't want to get too involved, but you can consider any two numbers that you start with. If you use the Fibonacci concept of adding the first two together, come up with a third, and keep doing that. If you divide just as you do in what's called phi convergence, your folks going to understand that idea. Well, you achieve phi convergence, which is taking those Fibonacci numbers and dividing the second one by the first and then the third by the second. You will asymptotically approach the Golden Ratio. Now, where I think a lot of people miss the boat in the sacred geometry world is they've come to believe, because they're thinking one-dimensionally, that you only achieve this phi convergence phenomenon if you use 0 and 1 as your starting numbers. You can start with any two numbers in the universe, and you will achieve this phi convergence in very, very quick order. So this is a lot to take in, but that's why that unit is so important, because you will eventually get to a phi scaling relationship. You just need to know how many units of phi that you're that's optimal, and that's phi cubed. And then we've got a scaling rate, which again you could scale with phi as a scaling rate. You could scale with 2 in the second example, or with any other numbers. So that, what I was trying to do here was say, is there any special combination of scaling unit and scaling rate that will allow for all of these values, these harmonic, geometric, and arithmetic means to all converge onto the very same points as the very numbers that we are achieving or are getting from this Fibonacci scaling that we're doing. So with that said, if you look on this next page, all I'm going to do, you can come back and look at this and then go back to Lawler if you want to see how this works. But if you look at the stuff in bold, this is a chart looking at all different kinds of scenarios. In the first, we started with a scaling unit of 2 and double scaling unit of 2 with phi scaling. You get the idea. I'm just trying all these different things to see what would work. Well, the only ones that work are where all of these relationships, whether they be the geometric mean relationship, the arithmetic mean relationship, the harmonic mean relationships, the only one where they all come together is when you have a phi scaling unit of phi cube, or a scaling unit of phi cube. And we're not going to go any further.
Hold on a second. Charlie, one sec.
Yeah.
Go back to that for a sec. When you say,
yeah.
I was looking at this when you sent it to me. When you say when they all come together,
I'm sorry, they stay in proportion.
With one another.
They stay in this. I'm sorry. Yeah, I said come together. They will all. I'm sorry. When I say they're all coming together, I didn't bring this up, but I said it, so now I'll discuss it. With the phi cubed scaling unit, and with phi scaling or any derivative of phi, whether that be square root of phi squared, it can be any phi related scaling rate, just so long as you have a phi cube scaling unit, the harmonic mean, the geometric mean, and the arithmetic mean will always fall on these exact points, like in the first two columns of point A and point C. So the arithmetic mean of point A here, for example, is 0.2361. I have a detailed formula that will break this out, but every one of the harmonic, geometric, and arithmetic means will all fall on either point A or point C.
Okay,
So now when we start to think about this in that regard, what that means is we haven't figured out how we're going to put this together in 3 dimensions, but every one of these waves, now we've got to start thinking about this in terms of waves. They're all going to converge at the same point. And that's where the harmonic coherence is going to come from. So we've gone further into this than but I'm glad you asked the question, because that's the right one.
Okay.
Next time I will have a detailed summary to show you exactly how that works, point by point.
I think if you were able to chart it out and actually show the numerically, like in a sine wave almost somehow, how they all meet at that coherence.
Well, that's right. Well, but you're going to do that here in a few minutes, because that's exactly what you're showing with the cone. So that's why I was waiting for you to come along. So suffice it to say, phi cubed scaling unit is very significant in terms of optimizing wave coherence. And that's what I think is key to a lot of the energy technologies, the implosion theories and so forth of free energy and of health and so forth that comes from the Russian pyramid research. So enough with that. Now, I saw that, and I still would love to, if anybody knows Richard Merrick, for example, because this is my next source. Richard would be able to take what I've just shown you, and he would be able to really explain this much better than I can. But he has written a book that if your readers have not read it, it's called Interference Theory, and he wrote it about 12 years ago. He is a musician, and but he is also a mathematician. So he's able to think in harmonic terms, and that's really the inspiration for me putting this information that I just showed you together from, was this book. But anyway, at the end of his book, he has a section on fractals. And for those of you who know this diagram is pretty famous in the world of fractals. It's called a Mandelbrot set. And what he shows is, son of a gun, we've got scaling at the scaling unit of phi cubed. So if you look at the bottom, this little circle here at the very left edge of this Mandelbrot set, he defined that as phi. Then the next one he defined as phi cubed. And then this larger circle is at the scale of phi to the 6th power. And then he drew, this circle around here. And sure enough, it came up to be phi to the 9th power. So phi cubed is now showing up as the scaling relationship in fractals themselves. So I knew that this was important. For those of you who are familiar with the work of Marshall Lefferts, several years ago, he wrote a book called Cosmometry, exploring the whole fractal nature of the cosmos. And he was doodling around one day, drawing these phi spirals. And one thing he noticed was that if he built a little model, I guess, that he could play with, so he could spin it around on a piece of paper and draw these spirals. But what he found was that if he anchored in the center here, in this case, and he went out 3 phi iterations, or phi cubed, and he spun that device, that he ended up with a circle. It won't happen if you do it in two, for phi or phi squared, phi to the 4th or anything. But if you spin that circle at the point of phi cubed, then you get this defining boundary condition, as he called it, when he drew those phi spirals. So again, I'm not a sacred geometer, but I said, wait a minute, this is phi cubed again. This is probably has something to do with this universal scaling. And when you think about it intuitively, if we're in 3 dimensions, then maybe phi cubed is relevant to scaling in 3 dimensions. It makes sense. But another example. But here's the one where it really hit home for me. The very last page of Robert Lawler's book has this diagram in it. And it was the first time that I began to see this in 3 dimensions. The Platonic solids themselves are found, and I know maybe it's not perfect, as you've shown me, George, but for a layperson, when I saw this, I immediately thought of Metatron's cube, because in 2 dimensions, you could expand it out to 3, and you could find all the Platonic solids. I knew that the Platonic solids had been theorized to be part of this creative process, that they kind of just like scales on the piano, you would run through the 5 forms, they would repeat and continue this process. But no one, Buckminster Fuller, did a lot of work on that, but no one had ever defined that process potentially within sacred geometry. So what I found was, when you look, Lawler gives you this information, but you've got the 5 steps here, the icosahedron to octahedron, star tetrahedron, cube, dodecahedron, and you start back again. Well, he gave the side lengths of these in the book, and sure enough, what do we find? The ratio between the first icosahedron side length and that of the next octave, as I'm calling it, is phi cubed. So once again, we're seeing this phi cube phenomenon show up. And I use this book, George, you may have a better one, but I didn't know where to start, and I didn't know anybody like you at the time, but I bought Kenneth McLean's book because it has all the angles, all the ratios, and I was able to just do this from scratch, to replicate what Lawler had done. And of course, I was able to do that. I didn't expect to find any errors, but I did independently replicate it. So this is just a real simple idea, but I took it and I said, well, let's see what happens if I scale all these things. I could take octave after octave. What I did, I took the side links, I converted those to, this was the ratio relationships that I got from McLean's book, the ratios of radius to side. And so I was able to convert that to radius and then to diameters. And sure enough, I found out that everything, it stays as it should in a phi cubed a scaling relationship throughout. So that's kind of where I was. Here's where I stop, and George is going to begin, because I said, all right, let's take this, let's go back to our pyramid, and let's put in the bottom point of the icosahedron, which I had figured the diameter at 3.0777. I put it in to its appropriate spot within the pyramid geometry, and then I did the same thing for the next octave up, which was scaled. The diameter was phi cubed smaller, and I put it in at 0.726. And you see the question mark. This is where I left all this information until 3 weeks ago when George called. So with all of that as background, I'm now going to turn it over and let George have fun. And I'm going to learn a lot from listening. So take it away.
Yes. Well, I guess I'll just go back to Charlie. When I first saw that video, towards the end of the first video I saw with Charlie, and you started talking about the Platonic solids, I just lit up. I mean, it wasn't, the Russian pyramid. I was like, Charlie is talking about this diagram, which I call the square view version, because you can draw the Platonic solids, of course, from what I call the hexagon or pentagon view. But I call this one the square view because it's usually contained in a square, right? It's very square looking. We've got square within square. So I was like, I know how to draw that, all the time. I mean, I draw it over and over and over again. And I have many, many videos that show techniques of how to draw this from this perspective. And of course, I was familiar with Robert Lawler's book, the diagram that Charlie had shown that was at the end of it. So I was like, I think I could add something to this because I can draw everything that you were just showing in the values of the ratio of moving everything at phi scaling, phi cube scaling unit, and show what that would look like within nested versions of these forms. So what you're looking at here on the left is a big octahedron, okay, this the blue one here, within a big cube. The black is basically a cube. So, when Charlie mentioned a moment ago, like when he looked at Robert's diagram and you felt like this was the first time you could see this, visualize it three-dimensionally through this perspective, is because, this is essentially what you're looking at here, just a three-dimensional model of what you're looking at. And I'll have to show this at the end when we go back to full screen, but you're looking at the outside of the big octahedron that's pointing right towards you in the front. And of course, we could show this from the side view, from a hexagon orientation. And I think there's something to what you said with your inspiration with Metatron's cube, and probably why it gave you some inspiration, but it didn't collect three-dimensionally. And just so your viewers know, like a big part of my work is really sharing different techniques to draw the Platonic solids nested in that diagram so that they do click three-dimensionally. So if you do look at that Metatron's cube drawing, it will look like three-dimensional scaling just as much as this does, because there's a little disproportions within that. And I think it's very important because these diagrams are meant to unlock that ability to see this 3D, to make these discoveries. So anyway, that's an aside. Whole many, many videos. Check out my channel if you're new to it to discover more about that. But what we did here, basically these heights that you're looking at, I just marked 3 of them here. This is based on the 1-inch cube. The next cube that you see here is the 4.23-inch edge length of the cube, all the way out to the VNC7, which is the 17.94 cube. So it's based on phi scaling. All these numbers are multiplying by 4.236, which is phi cubed. And as you could see, all the, we could go on forever. I mean, I showed Charlie where I stopped drawing the Platonic solids because there's no point in drawing the forms. Every form that's nested within this, whatever the in sphere or out sphere of those forms are, like just go back one slide, Charlie, to your numerics, right? One back.
Oh, I'm going the wrong way.
Way.
My mistake. Giving away the story here.
Yeah, so everything in here, right, is so the 1.732s over here, the star tetrahedron, cube, and dodecahedron. Of course, those are all neatly nested, so they're all going to have the same outsphere. But that is also moving at the rate of phi cube because it's all one thing, right? They're all linked together in how it's being shown nested. Now, this nesting diagram, go back a few slides to Robert's slide. There we go. It's a different measurement system because he nested the Platonic solids in a way that this dodecahedron, is this point right here, is where it's hitting the icosahedron. Now, in the scaling unit we're showing, and that Charlie's numbers were based on that he just showed, that dodecahedron is going to be down inside the icosahedron, as if it were built in this model. That's how it's shown in this model. So we're going to come up with different values when we do all this, but everything in this orientation is also going to move at phi cubed. So it really doesn't matter how we do it. It's all going to go to the next level in the progression, holding that phi cubed proportionality. So we could go back to my slide there, Charlie.
Okay.
So, you know, I'm doing this a few different ways. This is the first way I did it. And you could see I having nested pyramids showing up within here because each pyramid is basically going from the smaller cube, right? The cube, the sphere that you can look at this sphere right here, this big sphere, as either being around the octahedron, the blue, or being inside the cube. They share the same in sphere of the cube as the out sphere of that octahedron. Now that's the same, that pyramid that comes off of this black cube and that octahedron is going all the way up, and that hits the next one in the phi scaling ratio. So it's reproducing itself at these increments, and it's the same increments. For those of you who are familiar with Dan Winter's star mother model, this progression that we're showing here is just shown from a square view orientation rather than looking at it from the pentagon view, which would have a different orientation. But when you start to build the forms out around this, they're going to show up, as Dan Winter calls it, the star mother model of the dodecahedron stellation to the icosahedron stellation, dodeca. And when we do a full-on slideshow, I'll show people all these images so you can visualize this from all these other perspectives and what all these other forms are. I do have a few models here just to show. Well, this is one of the stellated icosahedron, as Dan calls it, and this is the stellated dodecahedron, a small stellated, and this is really a great stellated dodeca. But these two interface back and forth, one leapfrogging into the next, and they just go on. That's what this phi scaling angle within this is doing. It's doing the same thing, except there's a pyramid almost driving the momentum or imploding or exploding, whichever way you want to go. This angle is showing up throughout that whole process. Now, my latest one that I had Charlie drop in the beginning this is, you know, I started with the icosahedron or in many of my other drawings, but this recent one I did the dodecahedron and started with that being the base sphere. Numbers are all going to be the same, but basically what I have here are 3 spheres that I focused on, because when you put all the spheres in it, it gets very, you know, there's a lot going on. But I took the out sphere of the dodeca, which is around the red, and I took the out sphere of octahedron, which is this purple square, which is just inside that. You see, it's actually touching the vertice, the center edge of the dodeca. And then I took one more sphere, which was the icosahedron that's inside. This is the octahedron. This blue triangle on that octahedron face is actually an icosahedron. So I used this as the unit, right? And I built it from there. So what you're looking at are 3 spheres of those 3 forms of how they'll be reproducing at these scales as you go down. Now, here they're all together, right? But as soon as you start to go, all those spheres are going to maintain their own proportionality to one another. So we could basically recreate the same thing in each of these spheres, right? So you have multiples of these. But if you just take those three spheres, you can see that each of them are going to stack. All the red are going to stack on one another. All the blue are going to stack on one another. And all the purple are going to stack on one another.
Right.
And that's just demonstrating that all those relationships of that stacking that we're seeing are all the phi cubed relationships. So it's just basically looking at this model being expanded out towards this infinite point down here. But if we actually turn the model and looked at it from the top down, now picture you're viewing this from above, and you're looking straight down, you're looking at these nested Platonic solids from the top down, right? At this point G in the middle here. So you're looking at it all top down. You're not going to see that these spheres are coming towards you. You're going to see them as all nested, you know, it almost looks like they're all flat. They're almost like this, but they could actually be expanding up towards you as this octahedron's going too. So there's, I know, so much multidimensionality to this. It's hard to describe how you want to look at it because you're going to have Platonic solids infinitely expanding within this, but you also have them in each sphere. So there's just so much complexity we're really simplifying it, but everything's working out mathematically within the pyramid angle, which is, once again, the 76.345. That's the whole thing. And the phi ratio circles are matching within. And now you have this awesome Platonic solid connection, part of Dan Winter's work of the infinite non-destructive compression of charge, as he calls it. That's what's going on here in the Platonic solids, and it all is relating to these angles and these nested phi circles, right? So I hope that made sense, Charlie, and you were able to follow along at all. I mean, it's trying to do a lot with just one slide, but
no, that's right. That's right. And what I can tell you, seeing the diagram on the right now of the page, I would be fascinated. I want to spend some time. I started when I plotted the last page diagram that we showed earlier in 3D, I started to notice in the Z axis, there were relationships that were consistent. It's sacred geometric relationships, square root of 3, square root of 2, those square root of 5, that kind of thing that showed up. So I would imagine that if we went into GeoGebra or wherever and started to look at the ratios of these circles on the right, that we would start to find some very fascinating sacred geometric ratios as well, and even just on the absolute axis itself. So that's more research to do.
No, I think you're right. I mean, honestly, Charlie, this drawing I just did this morning on the right, so
Yeah.
I didn't get a chance to do all the measurements on it, but I'm
exactly.
thinking the
But
same way you are.
but that I bet you there'd be some very cool relationships. Again, nothing more than a proof that, when it's all scaling in the same direction, that's all we would prove. It's just another proof of scaling.
Definitely. So this is a Platonic solid connection that we're, still exploring and seeing how this, I mean, it really fits. I mean, there's more that we can dig into to find out. But in terms of how the forms nest one in one another, and how they follow the scaling, I don't know if Dan in his books mentions phi cubed much at all in it. But
I don't think he does. I don't think so. That's what's of interest to me. I tried reading his book. I didn't finish it, but I haven't seen him define the geometry of his implosion model. So I think this is it. I mean, and we're certainly going to be demonstrating that that's the geometry that other current technology implosion models in real life use. So I think it's going to be hard not to say that this isn't it.
And I think all your examples, I mean, the book is hundreds of pages of all this places that this angle shows up in temples, architecture all around the world, ancient sites. I mean, there's something huge to this. And
Well,
I'm really thrilled to see it find its way back into the sacred geometry
yeah.
pattern
Well,
language as I'm showing here and making all these awesome connections. So
I'm gonna just give the audience a little preview of what we'll do next time, but there are there's actually four current technologies that are in use that we know of that produce free energy that I can allude to that have this geometry. One is in the public domain currently, the power plant cooling towers that you see at nuclear and coal power plants. They use this geometry, and it's an example of the implosion model. But there's three others that are very, very important. One is the Russian pyramids. They have this geometry, and the research that they did, the energy field that was created by one of these pyramids was so enormous, they calculated it would take all of the electric generating capacity in the country of Russia to replicate that field. That's one. Two, Tesla's Wardenclyffe Tower, hidden in secrecy, but the geometry of that tower is exactly the same. And then third, we have Victor Schauberger's work, and I'll show pictures of this when we do another video, that his implosive technology with the Phi spiral all uses this geometry as well. Now, what's common among all three of those last three that I talked about? None of that information has made it to the public domain. So that should tell you maybe there's a reason why, and that this geometry is found there. So
yeah.
it's associated with all sorts of implosion, free energy devices on the planet right now.
Great. Well, I hope, having ways that, hobbyists or novices or whoever, right, having some access to working with techniques to start working with it. There's already new geometers. I posted some pictures of these cones you're going to see in a minute. They're folding up cones, checking out this stuff. It's like, there's so many creative people on Earth that are waiting to make these amazing discoveries for free energy and the things that you talk about that aren't in the ivory tower institutions. So, just being able to build this and construct it accurately on your own and learn these simple hand-drawn techniques is going to get you building pyramids. And before you know it, people who know how to make structures of no thermodynamics and whatever else you need to make something really energetic, like a Tesla of some sort, it's going to be pretty amazing. So it's really amazing work. And I'm thankful that we're here sharing some of this. Let's go to the next one, because this, I think, is going to touch on just what you're saying about the Phi spiral, because, once I started to take a look at the pyramid, I came up with this spiral diagram here. Now, these are the paths that a golden spiral would follow if you just started to curve around let's just take the blue one. That's 1.618, 0.38, right? So it's just following the progression of a golden spiral if we had a nice logarithmic arc going around it from these four anchor points. So what I did here was, the mid, where this touches the edge, this ball, basically the sphere within here, touching the pyramid face. The face is here. Look at the pyramid. So you've got this pyramid. That ball is touching somewhere on this face over here to the side.
I'm going to stop the share for a second so people can see that. There we go.
Yeah. So on the side here, you have this sphere touching at some point. Right. So when I turn to the side, that's going to be in contact. Now, the sphere is sitting inside. So it's not at the midpoint of the sphere, right? It's a little bit higher.
Right. A little higher. Yep.
You've got to locate where that point is. And then you've got to angle back to find out how to draw that sphere in there. It's all in sacred geometry. I could show you how to do this. I could show you how to make the
I wish I'd known that when I was doing it.
I could show you how to make the cones. I have a sacred geometry technique that will produce this cone, right? That's going to show you essentially what it is I'm talking about here, right? So this cone is inside this, and when I pull it out along this seam, that's the point along here where it's touching along the edge of the cone here, along the face of the pyramid.
Mhm.
Now, I was able to convert all that information to start to turn these spirals around, and I have pictures in the slides, but when you turn this towards you like this, and the lighting's a little poor for you, but what you see, these are going to be golden spirals as viewed from the top. Now,
Yes.
we often draw golden spirals as flat, and sometimes we stack cubes next to one another and go around, and you have this very long spiral that kind of goes like this. This is the rocket spiral, really, right? It is like a rocket, and Charlie pointed out when I said that, this is part of the nose cones of rockets, which he also has pointed out in his diagram, in his book and other videos, I'm sure. This is the path of the spiral that's going around very, very quickly as it makes it once or twice before it back to the top.
Right.
And that's the spiral from above. I have a single cone here, too, I think. Here it is. Maybe we can see the spiral a little bit better. We have images of this too, but let's get the light better. There you go. You could kind of see the spiral there, right?
Mm-hmm. Mm-hmm.
Circling around and going back around. Now, from above, that is a golden spiral. Let's go back to the slides, Charlie, so I could show that.
All right. Let's get back here. Okay, there you go.
Yeah, so this is a top-down view of the same diagram that we see here on the left, of the side view of it and the top view, and these are the same colors that are going around. And I had to start the base of the pyramid basically at the location of not the bottom of the sphere like we often see, but right at the point of where it intersects the sphere, basically, because that's the point of contact. So then it starts to work its way out. It goes to the center. So if you draw a parallel line across, it's going to touch there. It goes up to the next sphere. Now it's over on the back. Well, let me walk you through this way. Let's start with the blue one. That's on the left, right? You're going over. Now picture that's the back of the sphere right there. So this is on the back side of this three-dimensional object. You're going over to the right. Now you're at that phi ratio circle right there. Now you're going to go, this one's now towards you on front of the spiral.
Right.
On the face. And now it's over to the left. And it's just going to go on and on and on for each of these. Now we could reverse the spiral. And if you twisted this like a pine cone, let's say, and not just follow the 4 directions, then you have the geometry of a pine cone, basically, right? You can have maybe 13 rotations this way, 8 rotations this way, and they're not, perfectly geometrically centered like this. That will produce that kind of twisted pine cone effect that we're familiar with. So that's describing this. There's a lot more that can be done on this, but this is such an amazing example for me because literally 3 weeks before I discovered this diagram, I didn't know how to draw a golden spiral in the middle using sacred geometry techniques. The golden rectangle would always put the spiral origin off to the side when you drew that rectangle. So whatever reason, I found the technique that fit perfectly with the pyramid all within about a month's time of one another. So anyway, so just amazing sacred geometry. I hope that helps you view this. And if you view these circles that are going into the center as these stacked spheres, you can kind of almost look at like a sphere on top of a sphere on top of a sphere. These circles are going up over and over and over on top like that.
That's right. Very cool.
It's really stretching the mind's eye to look at these 2D images in 3 dimensions or more, and realize that you might have seen golden spiral drawings so many times. This can be flat. You can look at it that way. You can also turn the same spiral into this expansive model imploding at the top. There's so many ways you can go with it. So hopefully that helps the audience visualize that a little bit better.
Sure, that's perfect.
And now I have the cones on the next page, Charlie.
Okay.
So we can go on. So these are the cones I was just showing you. I don't have the pyramid in there, but you get the idea. It took quite a bit of math of figuring out how to get a cone to fit in with the same size. I mean, it took me a few days to make this cone accurately, because you want to get the cone edge to follow the 76.345. And this one, it was one of my first few attempts. I've refined it even better now, but it's close enough to get the idea. But there's the one golden spiral to go around, and here are the other ones from the basically 4 directions, 2 spirals coming off of each of those points. And that's what you see on the cone on the right. So, I like looking at this, like if you close one eye, sometimes you lose depth perception, but it is a picture, so you lose your depth perception. You could totally see that as flat, right? I mean,
That's
just
right.
spiral, and here it is. And now you're looking at all those images that Charlie has in his book of those ancient sites at the top of these temples, and you're thinking, whoa, that's what's going around here. I mean, it's all what you visualize, Charlie, like all your intuition on this and how you went about it. It's all in the sacred geometry that I know of the drawings.
Well,
And even with the Taurus that we're going to talk about and spiral moving through that, I mean, it's like all those
yes.
visualizations we came through from very different approaches, not even much influence on one another, no influence on each other at all, really.
Right. That's exactly right.
It's like you're just seeing like this is probably what it does. So I'm just like, let me see if the golden spiral does it. And I was like, man, the golden spiral goes right down. I'm blown away. Okay, so let's go on, Charlie. I don't know if I have any more.
Just to make a comment. Now, this picture on the bottom in the middle diagram, looking at the cone from above, that is in sacred geometric terms what I had figured out with those mean ratios and so forth. Because what it shows is that all of these location, everything lines up exactly on the same 4 sides at the same point vertically. So everything is in perfect coherence in this model. So all what you have done with sacred geometry is kind of what I had done with the math before. That's all I'm trying to point out.
I know. And I think we have to, like, as we've talked about, is, getting Dan Winter's drawings or his views on this, because he has drawings that look like this, right? From this top approach with the dodecahedron pentagon perspective. This is slightly different from the pentagon perspective because it's really based on this, I'd say the octahedron vertices here. But all these forms can move around in space. It's not like they're fixed, if they're on the surface of the sphere, they could be anywhere on the surface of the sphere. I mean, there's infinite points on a sphere, right?
Mm-hmm.
So we have this same version of the implosion that Dan talks about with the same type of pinecone kissing noses idea that he has for coherence that he describes showing up in this cone structure that also is his star mother model.
Right.
Showing the Platonic solids doing the same things. This cone is inside, which we'll see in a moment, of the nested Platonic solids and everything as well. So I think you might be on with the next bit here, Charlie.
Okay. Well, this slide, just as by way of introduction, a lot of the information that I got, I'd like to say that I did all the research for all of these things in the book, but people came to me with ideas, and one of these, this particular hieroglyph was shown to me by a young man in Australia named Michael Hoynes. He was actually using this geometry to make Ormus. He made a pyramid based on this, which of course is the same geometry. And then he saw one of my videos and contacted me. So that's how I knew about this hieroglyph. A little information about this hieroglyph. The people who decode these things, they've come up with the word give as the translation of what this meant. Now, initially, I thought it was maybe it could be give off or emit or something like that, because we know that there's energy fields associated with it. But now this is just by way of introduction. See what George has come up with.
Well, this is really one of our first inspirations. It was in our first meeting. I was showing Charlie this image that I didn't know about this hieroglyph. Maybe I'd seen it in some point. But I came up with this and I showed this slide. I'm like, well, here, Charlie, here's the Platonic solids. These are how these pyramids are nested. This is them off of all the spheres of the Platonic solids going down in, right? And I see Charlie rocking back and forth like he's in a burst, like he's got to say something.
I was.
I was like, Charlie, I was like, what's going on? And you're like, this looks just like the Karnak hieroglyph, and we checked it out to try. I overlaid it on top later the day to just see if there was anything that shows up. I mean, I'm not sure if this is 100% or anything like that, but there were some relationships between these black pyramids, because I'm doing them off of the icosahedron, in sphere and out sphere of the icosahedron, showed up at kind of roughly around that division, the dark area between the inner pyramid. And then this one showed up down in here. And that's this dark one that's inside the octahedron down here seemed to be the carved in one at the bottom. So, I'm just layering things over. It looks to fit all good. I'm not sure if there's a little, space or whatever, but it was definitely a huge motivation and inspiration, and realizing that this also had this Platonic solid connection. We always loved the ancient mysteries. Like, what is this really communicating? Give,
Yeah.
give is one interpretation, yet, highly sophisticated societies that built the Phi Giza pyramid, and I'm showing you that this is inside the Russian pyramid is inside the Phi Giza pyramid. Now, what does that do for thinking about this? And when we draw this Russian pyramid, we can draw it using the place where this intersects the sphere, the edge length of this intersects the sphere, to draw the Russian pyramid. I didn't show that, but I will eventually. So there's this huge connection between the Phi ratio pyramid and the Giza pyramid, that is, and the Russian pyramid. And, this is showing the angle too. This is probably who knows, maybe there's somewhere in the architecture of the internal structure of the pyramid. I don't know. I haven't done any research on that. I'm sure someone might want to check that out. There's probably something about this relationship that maybe we don't know. This is possibilities.
Sure. So, okay.
All right, we can go. I think you got the next thing. We're getting close to the end, I believe. Yeah.
Yeah, we are. This is actually the last page of the main part of my book. I have all of these concepts kind of at the back, but one of the things that I realized, I knew that if this is this geometry is that of universal Phi scaling, there had to be some kind of a relationship that would show up with the Taurus. And what I found, most Taurus pictures are kind of just drawings or hypotheticals, or you really didn't know what the geometry was that was involved with them. But this is actually an award. This is an award that's given out each year for what's called the Fundamental Physics Prize. It's the largest in terms of financial compensation science prize on the planet. And it was started by a Russian engineer, physicist, I believe. Mark Zuckerberg is on their board and so forth. But the key was, number one, I saw this geometry. I measured it and I said, ooh, this is pretty cool. Well, then I found a video, YouTube video person named Fractal Woman. Her name is Lori Gardi. And she has actually done, and I've got it referenced in the book, a 20-minute video about this very award and what she did to determine, she tried to sort of back or reverse engineer the geometry of this so she could build a replica of it. I've written this organization. I sent them my book. I haven't heard anything back, but I was hoping, or I still am hoping, to hear back. I asked to get in touch with the person who designed this model so we could get all of the specifics. And this was again before I met George, but George has now taken this to a whole new level and has been able to incorporate sacred geometry into this geometric form. So take it away.
Oh man, that is amazing, Charlie. I didn't know the background history of this this image.
Oh yeah, yeah. Oh yeah. I didn't just pick this out of the air, but this is definitely. I forgot to say, Lori talks in her video that it was absolutely important that she talks about the various things that she uses to scale, that phi was used in the scaling ratio when she the vertical plane of putting this together. That's the only way that she could get a perfectly spherical torus. So with that said, then I'm sorry I didn't tell you that, but yeah. So
Oh,
that's the
because
background on this.
that's amazing. Because I did this drawing on the right here prior to even seeing this image that Charlie sent me. You sent it to me in the slideshow. That take a look at the slideshow, and then
Right.
I was like, whoa, that because earlier that day or the few days before it, I was like, this is in the Platonic forms. I started messing around with the spiral, the cones meeting at the middle rather than coming out. Here's a pyramid here. I said, well, one of the techniques I draw this, they meet at the middle. So I was like, hey, two meeting in the middle. I'm like thinking Taurus, of course, right? And I'm like, oh, well, let's put it into the rhombic tricontahedron. Now, maybe your viewers probably don't know what that is. My viewers,
Mine won't, but that's okay. Explain it.
I'm looking for one here. Oh, here it is. I'll use this one. So the rhombic tricontahedron, well, actually, this one's better. The rhombic tricontahedron is these is golden rhombus faces, and it's a compound of two of the Platonic solids. And the compound means that basically, a simple way to look at it is that these two edges are crossing. Now, these edges, this big equilateral triangle that you see here, that's part of the icosahedron. Okay, I'm going to hold up an icosahedron for you like that. That's one icosahedron. So the long edges of the golden rhombus are an icosahedron. And then the dodecahedron are the shorter edges that are in that. And you're looking at that one like this here. So those two cross. So that's how you see the dodeca. That's crossing this point of the equilateral triangle. And you can see if I turn it there, there's that dodecahedron pentagon face, right? Okay. So it's a compound of two Platonic solids that are in golden proportion. And it's a very, very important form because it contains then all the other nested Platonic solids within it, right? So once you've got this compound, then of course you've got the cube inside the dodecahedron. Just to illustrate that real quick.
So I apologize. We had a little technical difficulty, but we're going to try to pick back up where George had left off and take it back to George. Go ahead.
Okay, yeah, great. Sorry, folks. I believe we were in the middle of just describing the dodecahedron and the 5 cubes that are in it based on the stars on the pentagram faces are actually 5 cubes. But I was just illustrating that within the dodecahedron and this compound of the icosahedron and the dodecahedron, the rhombic tricontahedron, the Goden Ratio rhombic faces, are all the Platonic solids in there. So, it fits nicely with the model. And that's the image that you're looking at, the geometric structure that's associated with the slides. So we can hop back over to the slides, Charlie.
Okay, hold on. There we go.
Great, it's coming on. Great, yeah, so that is this diamond rhombus that you see in the middle. That's the form I was just showing you. And like I was saying, Charlie, I didn't realize that this was a award-winning diagram. I thought that you had just, it's just one of these images that, are Taurus images that are gazillion out there, like you were saying.
Yeah,
So now
no.
to realize that this had this specific angle going on in here and that it was done based on phi scaling.
Yeah.
I guess I should have known there was something special to it because I didn't expect the circle around it. So this golden circle that you see here is touching the faces, the inner faces. It's the inside sphere that is in this compound form. So that's actually the sphere that is showing roughly where this shape of this torus, and here's the angle going down to the center. So when I did the drawing before I saw this image, well, I had those two cones going up. And at the top edge of this, I decided to, draw the cut the top of the circle, like, with the circle on top. So this sphere that you see on top, just flip it in your mind so that it's laying flat. That's going to be like a little hole at the top and bottom of the circle that we see. So we could really, if we wanted to, we could reconstruct this out of a sphere and make these cones in it. I was thinking of making that model because we basically have all the parts to do what the woman you were talking about wanting to reconstruct that. We could easily make the model. Now, we're just putting these two cones together like this, tip to tip, and then just picture a bigger circle, sphere around top of this.
Right.
And the one important thing to mention here is that this rhombic tricontahedron, I didn't think I was going to share this part, but it just came to me. And we want to see this big at the end.
Let me stop the share on the screen now. So people can, okay, there we go.
This is a video that I have on the Earth grid, right? So the Earth grid is this, the colored great circles that you see in here is all contained within this tricontahedron form. And what you'd be looking at, where that cone is going down into the center, is right at this intersection of where this blue line is. That's the icosahedron. I can't put the other one in, the dodecahedron, because it run into that one. But this is the red struts on this are the tricontahedron. So picture those cones, the 76.345, basically going to every middle of every rhombic face on this. And these are the sacred site. Sacred sites line up to these vertices and places and locations.
Oh, how amazing.
Sure.
Oh, wow.
This tricontahedron is, there's a lot to it. This is what the Earth grid is based on. There's videos that I've done on the Earth grid. My most recent one talks about how I constructed that form. So there's a lot more that we can look at. So when you look at the Earth as a torus, as a sphere, that has these cones of energy that are, in it, and you have that torus diagram that isn't just a simple torus diagram, as now that I understand it, and we're placing these cones in relationship to that sphere that's inside the form. So it's really about the spheres that are contained within this form, and even the circles and spheres that the pyramid is, in my mind, kind of showing the geometry, like it's a vessel to hold this spherical geometry. It's, so anyway, that's what that form is about. So we could go back to the slideshow and then people can visualize that a little bit better.
Okay. Well, one thing I will do now that we put that information together, I will put into the notes of this video, and I'll send it to you, George, the link to the YouTube video that Fractal Woman did on this particular award, Taurus.
I'm very excited to see that.
It wasn't completed. I did try to contact her about a year and a half ago because I wanted to get a copy, see if I could borrow her Taurus modeling software. And, she said it was proprietary. I get that. But anyway, she may remember me from that, maybe not. But anyway, it was instructional for me, but I'm sure that you're going to be able to take it to a whole new level too. So once you understand.
Charlie, I mean, the amazing thing is like, I'm doing this all that I could do it with hand-drawn drawing techniques. We don't need, that's the beauty of this, is you don't need the crazy sophisticated models to do this. We're showing that the sacred geometry is showing you the sophisticated models. It's right here.
That's right. That's right. That's true. That's true.
How to draw this, right? So that's the thing that's very empowering, I think, in understanding to the common lay person who doesn't have all the technological skills to do this stuff. You could draw this, which we're going to do, or at least I'm going to do at some point, is do classes, that are going to do little workshop drawing things and teach all the geometry of all these forms, how to build the, I think we talked about ideas of doing things like that. So I think we should pursue.
Well, and I can see already that if we can teach somebody, even my audience is going to be excited about learning how to make a pyramid without having to buy PVC pipe or whatever. They can figure out how to figure the dimensions at any scale just using a protractor and a straight edge. So I think that's amazing. So looking forward to it.
I mean, I
Yeah.
built all these models just from doing the drawings like that. And so
Yeah.
I think it's great. I think the more people that have access to this, the more pyramids will be unearthed and the more healing benefits that you have documented, the researchers
Yep.
have documented, and you've
Sure.
brought
Sure.
together to share all those insights is
Yeah.
very powerful effect. And, many of the sacred sites could rebuilding your sacred site right around your home with these pyramids, right?
Well, that's
So,
right. That's exactly right.
um, we've got, I just want to illustrate one other little drawing here that's on the side is this
Sure.
circle over here. That is the two spirals that are going down the cones from above and below. So once again, classic yin yang type of design.
Right.
Picture this as a curve this way and a curve this way, spiraling
Right.
in toward the center point. That's what this little cone would look like from above, the purple circle looking straight down. It would be a flat image like that, right? But now you're seeing it going through the whole length of the sphere that's containing the cone, right?
Mhm.
So it's very interesting to really have a look at these two-dimensional designs you're seeing and start to visualize it in all this beautiful interconnected holistic sacred geometry that is real structure, real DNA, real earth grids, all of it is got a relationship to these two-dimensional drawings that we love to look at.
Wow.
So
Much more to cover, but I think we're about out of time for today. So
I think so. What do we got? What's the last slide? The thank you, Charlie?
well,
Oh, you got
that's
to
it.
show that.
Oh, I didn't show the thank you slide. I'm
Yeah,
so
yeah.
sorry. Forgive
You
me.
really like you really like the
This
thank you.
this is this is a great slide for those who have not seen it before. Let me get it up here. I don't have it in slide mode. Now I will get it into slide mode. There we go. And there it is. Yes, even the symbol for Namaste has this sacred 76-345 geometry. So I
Nice.
think that's a great takeaway for today's show. And I really appreciate, George, the tremendous insights that I know you've given my audience, and I hope I've done some for your audience as well. So
Oh, you
uh,
certainly have. And Charlie, when you back out of that, did we want to mention a little on Robert Lawler? We did discuss that.
I do. Yes, let's do that. Let's skip out and yeah, show one of the things that I've been trying to do for the last couple of years, ever since I realized this relationship between the Platonic solids and this geometric form, was to get in touch with Robert Lawler. It took a long time. His publisher didn't get me. I called them, I emailed them. It took actually going to a publisher, not of the Sacred Geometry book, but one of his other books through Inner Traditions up in Vermont, and they took my information, got it to him. Long story short, the night I was supposed to be in touch with Robert this previous summer, I had it set up to go over. This was before I met George, of course, but he fell and broke his hip, and really was in poor health. As soon as George and I met, George put together a bunch of slides, many more than what we've shown you here today. And unfortunately, we sent that out last week, and I just got a notice, 2 days ago, that Robert has passed. So I know you've got something that you've kind of put together, kind of in memoriam to his efforts. And I have to say, without Robert's book, I certainly would not have been able to put all this information together. So I'm very,
Yeah.
very grateful for Robert's efforts. And I'll just let you say a few words and show your
Yeah, I mean,
memoriam.
I'll probably do a separate video as we discussed and just discuss some of the book. Here's the book and the drawing in the back that has been inspirational for both of us.
Yeah.
So many people start. This is probably his book is just probably probably I'd say the best nuts and bolts mathematical version of sacred geometry, teaching you the techniques of all the square roots. I mean, it's just been phenomenal to have that resource for so many years. And I feel like we're just even starting to unlock some of it. So it was quite a bummer for both of us to send off all these informations and the nesting of the Platonics in relationship to the pyramid, to find out that news. Yeah, both Charlie and I feel like, you know, through the ether, we're getting the connections and you know, the guidance. And you know, I've never done the drawing, so this is my one little drawing that I did today. Just the same one that Robert has in the back of his book, with the unique design of the Platonic solids and the 9 concentric circles. I did this about a half an hour before Charlie and I went on. I'd been like, I've never figured this out, but if I've learned anything from sacred geometry, from everything I've learned from his book, now's the time to do the drawing of the last page in the book.
Right.
And I really want to thank Charlie too, and of course Robert, for bringing this drawing to our attention. And there's a lot more information to learn and glean from this. I did exactly to the scale of all the dimensions that are in his drawing. And I think when you connect with the drawer or the person who brought that, you connect a little bit with their essence of something they brought to you. So I really felt kind of special connecting to the drawing that Robert had in his book there. So I'll probably share more on that drawing in a separate video and talk about Robert's work there. So thanks, Charlie, so much for all the inspiration. And just one last bit. I mean, I wouldn't have contacted Charlie unless I was looking for a video couple of weeks ago on Robert Lawler talking about sacred geometry, and I came across Charlie in that, and we got this close to getting the information to Robert.
So for my group, I want to just let, and for yours as well, I mean, we're going to be doing another video on my channel on the 21st, and if technology allowing, we're gonna have a double live stream to George's channel, New Geometry, and we'll be able to take questions as well on that live stream, so that those of you who see this ahead of time, please, you know, mark it on your calendars. That'll be at 1 o'clock on Wednesday, December 21st. So we're looking forward to that event. And if you, again, you'll be able to talk to George or me about any questions you may have. And we want to get a community really started here. That's why we're going to do this joint live stream together on the 21st.
Awesome. Thanks, Charlie. This was really fun. It was so great. And I can't wait to see people's comments. And I'm just so thrilled to have shared this information and put our two together. So thanks again, Charlie, for being here on this new conversation. And until next time, everybody, please show up on the 21st. It's going to be awesome.
All right. Have a great day. Thank you.
All righty. Bye-bye. See you, Charlie.
Bye-bye.